Hello, everybody. I'm going to give you a video lecture on cosmology, which is going to wrap up astronomy for us. So I could have probably pulled some YouTube videos for that, but I think it'd take me just as long to record something because there's several things I want to cover in this video. I'm going to kind of review everything we've been going over so far and end things by talking about the universe as a whole. And then you guys will have one more day. I'm not going to have a video lecture for tomorrow, but one more day about learning about universal motion. So let's get started talking about cosmology. So cosmology, not the same as cosmetology, which is the study of makeup. Cosmology is the study of the universe. So what do we mean when I say universe? And by the way, that last slide said astronomy day 9. Should have said astronomy day 8. Okay, so I'm going to move my face around a little bit, guys. So first of all, the first thing we talked about with astronomy is that the Earth's shape. So the Earth is round. People have known that the Earth is round for a long time. That's what antiquity means. People have basically known that for a long, long time. If you hear people saying that the Earth is flat, it's kind of a relatively new thing, believe it or not. There were some civilizations that might believed in that, but for the most part, for scientists anyway, maybe not for an everyday person, but for scientists, it's really easy to show that the Earth is round. Then one thing that we talked about, you might have read about, is something called the geocentric model. So knowing that the Earth is round, geocentric model is really people's first view of the universe. The geocentric model is the belief that the Earth is at the center of the universe. And that the sun, the moon, and all of the planets and the stars go around the Earth. And really, this belief isn't too far-fetched. Based on just pure observational evidence, it looks like things should go around the Earth. So we see the sunrise every morning, we see it set every evening, and if you pay close attention, which people before YouTube often did, we can even see the moon rise and the moon set, and the stars rise and the stars set. So it looks like everything is going around the Earth. So this isn't really too far-fetched of an idea that everything is going around the Earth. However, when you really start to measure very fine things, like very fine detailed about some motion of the planets, planets look like they go around the Earth most of the time, but then some planets look like they go backwards and then they go forwards again. That's called a retrograde motion. So there are some things about this theory that don't really work if you really look very closely, which is what someone named Nicholas Copernicus did and someone named Galileo Galilei. These two men both looked at the universe and said, the Earth looks like things should go around the Earth, but something's not quite right about these theories. Nicholas Copernicus was the first man to publish the idea that the Earth is not the center of the universe, but the sun is the center of the universe. He actually published this idea on his deathbed because it was considered heresy to think anything besides the Earth is the center of the universe. I say heresy because at the time the Catholic Church held the belief that the Earth is at the center of the universe. To think otherwise would be unbiblical, according to the Catholic Church. And so he published this idea on his deathbed because he was afraid of getting kicked out of the church. And Galileo Galilei was not afraid to publish this idea in his lifetime. He agreed with Nicholas Copernicus. By the way, Galileo lived about 100 years after Nicholas Copernicus. And the church actually challenged this on his point, and he was almost kicked out of the Catholic Church before recanting his ideas. So this was kind of a dangerous. The heliocentric model was a dangerous idea about the universe, that the sun is at the center of the universe. However, eventually, even the Catholic Church conceded that observational evidence, if you really look at the sky carefully and measure it carefully, yes, the sun is indeed the center of the universe. That was the idea at the time. Now, again, let's go back to that word universe, because universe doesn't just mean the sun and the planets and the stars. It means everything, even outside what we can see. The reason I'm saying this is because while it looks like the sun is at the center of the universe, we'll soon find out that the sun isn't even at the center of our own galaxy. So let's talk about what the sun is. And actually, you guys have been studying about this, so I don't have to touch on this too much. We know that the sun is really just an ordinary star. There's nothing too special about our sun, which is good for us because we don't want one of those extreme stars that's really too hot or really too dim. We want something just in the middle. And our sun is perfect for us as an ordinary star, but it's one of thousands and thousands of stars in our galaxy. So to learn that the sun was just like any other star was really a big leap in the field of astronomy. And so it wasn't too long after that until we thought, well, the sun might not be the center of everything after all. Um, and so to learn to go from the earth is not the center of the universe to the sun is the center of the universe, and then to go to, well, maybe the sun isn't at the center of the universe. And so for a while, the center of the universe wasn't really too big of an issue. Nobody really cared what was at the center of the universe as to what the universe actually was. We learned that the sun is part of something called the Milky Way Galaxy. So our solar system is kind of on the edge of the Milky Way. If you can picture our Milky Way Galaxy like a quarter or like a coin, because our Milky Way Galaxy is pretty flat if you go out far enough. The sun is kind of toward the edge of that coin. We're not really close to the center. If we were, the sky would be a whole lot brighter. But let's just talk about the Milky Way for example, for a second. It's called the Milky Way because if you're in a really dark part of the world where there's not too many city lights, you can see this big band of light and shadow, and that's nicknamed the Milky Way. That's looks like a big stream of milk going across the sky, which is how it's got its name. But just to picture how many stars is in the Milky Way, astronomers now estimate that 100 billion stars call the Milky Way home. And that's a lot of stars. So just to think about, if you were to travel outside the Milky Way and then try to find your way back home, you better have a really good map to find your way back home to the sun. Imagine for a second picking up a handful of sand and then trying to pick out one grain of sand from that pile of sand. And you can pretend that the pile of sand is the Milky Way, and that one grain of sand that you picked up is the sun. So you have the sun in your hands, right? Put that sun back in the sand and then mix all that sand up. So you mixed up all of your stars. Now, what are the chances that you could pick up the same grain of sand that you picked out at the first time? Or what are the chances that you could even dig through that pile of sand and find the exact same grain of sand? It's not a very high chance. To try to find the sun among all the other stars in the Milky Way is not an easy task. That's kind of just give you an idea of how the scale of the Milky Way galaxy, not even just the universe, but the Milky Way is huge, is enormous. And which brings me to my first important fact about this slideshow, is that a galaxy is a large collection of stars, very large. Like I said, the Milky Way has 100 billion stars, and it's not even by far the largest galaxy that we know of. So the Milky Way Galaxy, how do we get this picture? So I just wanted to think about that for a second. The satellite that has traveled the most distance that we have sent has just left the solar system about a little bit less than 10 years ago. And remember, our solar system is just a tiny part of the Milky Way. So how can we get a picture like this? Well, this isn't actually a picture. This is an artist rendering. So scientists have built this map by looking from the inside of the galaxy, which is actually a pretty hard task. I mean, right now we're kind of confined to our houses. This is if you're watching this during the coronavirus epidemic of 2020. And imagine trying to build a map of your city from scratch without leaving your house. That'd be pretty difficult. You only have what you can see out the window to go by. So that's basically how we built this map of the Milky Way, is that we just looked out into the galaxy, but we haven't left the solar system, yet we can make astonishing images, or what we think what the Milky Way looks like. So having maps like this is really cool. I can't exactly tell you where our where our solar system is just by looking at this picture, but again, we're somewhere on the edges. And here's a little fun fact. How long would it take to drive across the Milky Way at 90 miles an hour? It would take about 800 billion years. So think about that, going highway speed to go from one end of our Milky Way to the other, 800 billion years, about 80 billion lifetimes to get across the Milky Way. That's a lot of time. There's also some other fun facts here about light, how fast light moves. I'm not going to go through all of them just to keep this video as brief as I can. But if you're going the speed of light, it would take you about a 1/1000th of a second or 1 millisecond to get from St. Louis to Kansas City. At that very, very fast speed, it would still take you 100,000 years to get across the Milky Way. So the Milky Way is unimaginably huge. And like I said, the Milky Way is just a small part of our universe. So it's really hard to get a grasp on how big the universe actually is. So let's talk about this man, Edwin Hubble. Edwin Hubble lived at a time in the 1930s. So at this time, this is long, long after people accepted the heliocentric model. And actually, they moved past the heliocentric model. They already understood that the sun is not the center of the universe and not even the center of our own galaxy. Edwin Hubble, if you look at the readings I posted on CK12, he looked at these smudges in the sky that people call nebula. A few of these smudges looked a little bit off to Edwin Hubble. They had some strange properties. And the Andromeda Nebula, in particular, was one of his first discoveries. He actually discovered that the Andromeda Nebula was not a nebula at all, but a galaxy. Edwin Hubble was the first person, or one of the first people, to discover that some of these nebulas are actually whole different sets of stars. Before this time, people used to think that the Milky Way was the only part of the universe, that there was nothing outside the Milky Way. But once he started measuring distances to what people thought were nebula, he actually discovered these are actually whole new galaxies with whole new sets of stars and solar systems. So Edwin Hubble kind of expanded our idea of how big the universe is. We went from the Milky Way was the only galaxy to exist to, oh wait, there's more than one galaxies. And actually, he discovered dozens of galaxies. But Edwin Hubble died before discovering this next part, and so he left behind kind of a legacy. If that name Hubble sounds familiar, that's because we named something called the Hubble Space Telescope after him. So I'm going to show you his legacy, what he left behind, or I guess what we learned after him. So the Hubble Space Telescope was a phenomenal instrument, and we could peer into the universe in detail like never before. We got really good, so this was about in the 1990s, we got really good pictures of the solar system, the planets, stars, nebula, galaxies. So, NASA and all the countries around the world had their heyday with the Hubble Space Telescope, taking all of these great pictures of these things in the 1990s. But then researchers decided to do something kind of interesting with the Hubble Space Telescope. Instead of pointing the space telescope into somewhere where there's lots of light, they pointed it into a dark region of space. Why would they do that? So to describe why they would do that, let me describe the picture you guys are seeing with all this lightning. So if you haven't figured it out, this isn't just a snapshot. You don't find a thunderstorm that unleashes 1,000 lightning bolts all at once. This is called, I lost the word for it. I'm sorry. So what happens is that instead of a photographer, let me back up. So almost everyone uses phones nowadays, right? So the way that your phone works is that there's a lens here. And the lens opens up, or it kind of digitally opens up for a split second whenever you take a picture. The shorter the exposure time, usually the better, because if this lens opens for more than more than a fraction of a second, that's how images get blurry. If you have a blurred image, sometimes it's because the lens is open for too long. It captures too much light and there's too much stuff going on. So really, it's good if your lens only opens for a fraction of a second. And I'm sure these phone makers know a great deal about that and know what exposure time you need to balance the amount of light you need versus the amount of motion you need. However, open exposure photography. That's what I was trying to think, the word I was trying to think of. So the picture you see here is open exposure photography. So if you have your camera on a very still tripod, that blurriness issue isn't so much of a big deal. So if you can keep your camera still enough and keep your camera lens open for long enough, you can gather lots and lots of light. So what this particular photographer did is he had his camera lens open for maybe half an hour, maybe an hour, maybe just 15 minutes. And he captured all of these lightning bolts within that time span. And so he's able to make beautiful pictures like this. Going back to the Hubble Space Telescope, the reason why astronomers chose to point the Hubble at such a dark patch of sky, they kept their lens open not for an hour, but for 3 days. And the thinking behind that is the way that our eyes work is that even though our eyes tell us that, hey, that's a very dark patch of sky, if you keep your lens open for long enough and the film can catch as much light as possible, you can catch things that your eye wouldn't normally be able to see. So after keeping the lens open on the Hubble for 3 days, this is the picture that they caught. It's called the Hubble Deep Field. In this picture, what you're seeing is lots of dots and smudges of light. Again, this was a dark patch of sky until they kept their lens open for 72 hours. So there are some points of light on here that are actually stars, but almost every single point of light you're seeing is not a star, but galaxies. Now remember, before this picture, we only knew of a few dozen galaxies, but there are hundreds of galaxies just in this one picture. And this isn't even the entire sky. This is just one dark patch of the sky. So we found hundreds of galaxies just in this one picture because we were able to point our Hubble Space Telescope into a very dark patch of sky. So they were impressed by this. There were so many galaxies in the universe that we didn't know about. So they decided to do this again. This is Hubble Deep Field South. Again, every single point of light you see is a galaxy, not a star, but a galaxy. Very distant galaxies. And we have done this over and over again. You can look at the slideshow and just see the number of galaxies that we've discovered in the universe. It's amazing. There's too many to name, too many to see. And every direction that we look in the sky, if we keep our cameras open for long enough, we can see many, many galaxies. So our universe contains so many galaxies. It's a number that we can't even count. There's more galaxies in the universe than there are stars in our universe, definitely. So my last fact I want to share with you guys is that the universe contains all of space and time. It is made of many galaxies and other material. Tomorrow, what you guys are going to learn is that our universe is moving. So we know that the Earth moves around the sun, and we know that the sun moves around the galaxy. And actually, galaxies themselves are moving, but they're moving in a very specific manner. If you guys look at your reading closely from today, you will see that every galaxy that we look at is moving away from the Milky Way. And to explain that motion and why it's happening, I encourage you guys to watch the videos and do the reading tomorrow about why the universe, which direction the universe is moving in and why it's moving that way. It's a very interesting concept. I hope you guys enjoy it. Have any questions, please don't hesitate to contact me. Thanks for watching, and I'll see you in class.